Will proceed in vector and energy commercial calculus. Vector come vector come vector energy commercial calculus. This is the arena in which we are pursuing the discussion. Mind blowing, amazing. What we have seen till now, the flux coming out of a surface. Okay, there is a liquid that is flowing, and it is passing through this surface. Okay, how it will pass through this surface? It has no hole. Okay, in that sense, it is passing through this surface. So the kind of the scenario is that there is a liquid and it is passing through this surface. And how much liquid is passing through this surface? There is a hole. So liquid velocity multiplied by the area, that much is the volume per second the liquid is flowing out of the surface. That is called flux. Flux means meter cube per second. If there is a fluid that is passing through a surface, then through this surface, how much meter cube per second is coming out of the surface is the flux of the surface. So that we have seen. Now, how to calculate? Okay, I mean this is a kind of very crude way. Tell me little bit better way. Okay, we will tell little better way. Velocity into surface area. What about if velocity of liquid is like this and this is the surface area? Then velocity vector dot product with the surface area vector. That is the fluid. If velocity of the liquid is exactly like this, then nothing would come out from here. What is the direction of velocity? Velocity direction is along the fluid. What is direction of the surface area? That the line that is perpendicular to the surface area. So this line is perpendicular to the surface area. This line is perpendicular to the surface area. This is called surface area vector. Velocity vector dot product with the surface area vector. Velocity vector velocity vector dot product with the surface area vector is the net flux. If velocity vector is in this is x axis, this is y axis, this is z axis. If velocity is in z axis and surface area is in x axis, z dot x 0, nothing is coming out from here. Okay, that we understood. And I know that how to calculate surface area vector. Wherever surface is, just see the perpendicular to it and you get the surface area vector. Isn't it easy, right? It is pretty easy. So if the surface is flat, then surface area vector is exactly a line that is perpendicular on this flat surface. Understood. Okay, so what is the flux? Velocity vector dot product with the area vector. That is the flux. Now we have talked, consider, okay, I'll proceed on this, but the way I produce a kind of different kind of surfaces. So we were talking about round surface. So I have I have a round surface. Now tell me. Okay, so up. Okay, this is the surface. This is the surface. Tell me the surface vector. It is not flat. Okay, let me focus here. It looks like little bit flat. This is the surface area vector. At this point, everywhere surface area vector is different. Can you see it? Okay, if I ask what is surface area vector for this is xy plane, then this is everywhere it is z vector. Everywhere it is z vector. That is the surface area vector. Everywhere. I can just write, consider the surface area is 100. 100 centimeter square. Then what is your surface area vector? 100 K. This is my area. What is area? That's why vector is considered as the complete mathematics. Vector is considered as complete mathematics. It is considered as complete mathematics because we have area and it has a direction. Can someone believe it? If someone is giving, someone consider you are buying. You are buying this. Okay, you are buying this. What is the surface area of this? Then someone would say 200, 200, I am sorry, 200 centimeters square. 200 centimeters square. That is the surface area. No, 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 no. Not 200 centimeters square. That is magnitude. Yes, magnitude. What is the direction? What do you mean by direction? Okay, so vector adds direction to the magnitude. Okay, so what is the surface area of this? Someone may calculate. If it is a sphere, then 4 pi a square. If there is a is the radius, 4 pi a square is the surface area. If that is the case, what is complete thing? This is the magnitude. Tell me the direction. Direction is variable. Here surface area direction is this. Here direction is this. Here direction perpendicular at that point. Direct. Okay, then surface area vector cannot be constant. If it was a surface xy plane, surface area vector all along the xy plane was k vector, k unit vector. But if I just talk about direction without magnitude, but here surface area vector will have direction. I'm sorry, direction. What is the direction? Surface area direction is how much? We now we but it I mean anyone would say this is not constant. Okay, if you take xy plane, everywhere surface area vector is k vector, but here everywhere surface area vector is different. It is variable. Looks like it is an algebraic vector. Yeah, it is algebraic vector. Now if I keep this, if I keep this on on xy plane, if I keep this on xy plane, if I see from the top, then on the xy plane there will be a circle. On the xy plane, on the xy plane there will be a circle. If I see from the top, on the xy plane there will be a circle. Okay, now on this circle, if I take any x comma y and calculate function over x comma y, that will be a value, and that value is perpendicular to the surface. Every x comma y, if I keep measure fxy, then it will make the sphere. What is the fxy? What is hidden fxy? Okay, x and y, I can pick anything. That is inside the circle that I see the sphere top. Okay, what is your fxy? Okay, for a sphere, the fxy is the square root of a square minus x square minus y square. That is fxy. Means if you take x, y as origin, then fxy, that is the height, is a. So if the sphere, if sphere is center, if the sphere is centered at the origin, then half of the sphere is above, half of the sphere is below, and origin is blue color. What we see blue color is the origin here at the middle, and then half of the sphere, hemisphere, top hemisphere is above, and bottom hemisphere is below. If you see, then at origin, at origin x equal to 0, y equal to 0, z equal to square root of a square. That becomes plus minus a. Plus minus a means at origin the height is a and bottom minus a because it is centered at the origin. What about x equal to a? Y equal to 0 on x-axis, then it is 0 because sphere is like this. When I see at x equal to a, it will be completely end of the sphere. Y equal to a, x equal to 0, end of the sphere. X equal to 0, y equal to top of the sphere. So this is the fxy. Fxy is square root of a square minus x square minus y square for a sphere. For different kind of surfaces, this fxy or z relationship with x and y will be different, and this is how it makes different kind of surfaces in 3D. Okay, so we are talking about calculating the flux. Now flux is velocity vector dot area vector. Okay, if area vector has dependent and independent algebraic equation, and velocity vector has dependent and independent velocity algebraic equation algebra, then dot product cannot be calculated by directly multiplying the algebra. The way I always say, x into x is x square when both are independent to each other. But one x is dependent upon other x, then x into x is x square by 2. This is integral calculus. Okay. Similarly, if I have the flux net liquid that is coming out of this sphere, flux, if there is a fluid that is passing through a surface, how much fluid is coming out is velocity vector dot area vector. If velocity vector is algebra, and inside the algebra there is independent and dependent component, inside the area there is independent and dependent component, then the dot product I cannot go with direct multiplication. I have to use integral calculus. Integral calculus means I have to find velocity vector dot d, that is differential d of something that will internally become a area vector. Velocity vector dot area vector is the net flux. Velocity vector dot d of something you find, so that if you do the differential it becomes area vector. That is position vector that we talk. So velocity vector dot d of area position vector. Area position vector is the net integral. D of area position vector becomes area vector only. But we have to use integral calculus because there is independent and what independent and dependent component you are talking about? XY plane is independent component that constitute x axis and y axis, whereas fxy z is dependent component, and everything is available in the equation. If you see the area vector, now you have to calculate area vector, whatever it is. It is d of position vector of the area. Now mind-blowing proof we gave that d of what is d of position vector? Okay, d of position vector. If it is centered at the origin, and if I take any point on the surface and from center, if I draw a line, that is called position vector. And that is if this point is x comma y comma z, then from center if I draw a line, that position vector is xi plus yj plus zk. D of position vector is the area vector. Okay, whatever it is. D of position vector is same as d of position vector divided by d of xy plane into d of xy plane. Make sense? I believe very detailed we have talked in the past video. D of position vector divided by d of xy plane into d of xy plane is same as d of position vector. Net flux. We gave examples. There is an electric charge of Q. I don't know what is the charge unit for the Q. So there is an electric charge Q that is kept at the center of this sphere, and from there electric wave is generating. Now the equation of the wave is Q into R vector. R is a spherical coordinate system outward from the center. This is R. Q into R vector divided by R to the power 3, that is the electric field that is coming out of from the center. Consider electric field is a fluid that is coming out. How much fluid is coming out of the surface? When the surface is a sphere, it is located at R distance or A distance from the center. Then how much electric field coming out of the surface? If electric charge is kept at the center. Okay, if that is the scenario, then the electric velocity, the electric field velocity, the liquid that is coming out, consider electric field as a liquid. The liquid that is coming out is Q R vector divided by R to the power 3. In Cartesian coordinate system, it is Q R vector is xi plus yj plus zk divided by r to the power 3 x square plus y square plus z square to the power 3 by 2. Velocity vector v dot d of position vector or d of area vector. Area vector, I don't know what is area vector of sphere. So dot d of position vector. Position vector is xi plus yj plus zk. D of xi plus yj plus zk. Roughly someone can say dxi plus dyj plus dzk. Roughly. Anyway, d of position vector is same as dp divided by dxy plane into dxy plane. Now d of position vector by dxy plane is what in calculus? D of xy plane. If there is a change in xy plane, then how much change in the position vector of area is seen? That is d position vector by d of xy plane. What is d of position vector by dx? Dx. Okay, if there is one unit change along x-axis, how much position vector p is changing? Let's say dp by dx, dy by dx. If there is one unit change along x-axis, how much y is changing? dy by dx, dp by dx. If there is one unit of change is happening along x-axis, how much position vector is changing? dp by dxy plane. If there is one unit of area dxy, there are x and y, two independent components. If there is one unit of area change is happening on xy plane, then how many unit of p area position vector is changing? Okay, that is the scenario, or more or less someone can understand this, that this sphere is centered at the origin. So if it is kept, if it is kept, if I pierce it and it is fit inside here, it is kept like this, and then if on this surface, then it will make a circle on this surface. Hop, 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 hop. If I see down, keep the sphere centered at the origin. If I see down, then it will make a circle. Now if I tilt this, then there is a lower portion of a sphere on this side. If I see down, again it will be a circle. Now on this circle, if I take any point x comma y, at x comma y point, if I make a small rectangle whose width is delta x and height is delta y. Now there are 2 points. One point is x comma y and there is another point at the other end of the rectangle is delta x plus delta x comma y plus delta y. Now this x comma y, now this x comma y here would map point P here. Then x plus delta x comma y plus delta y would map another point P1 here. Okay. Now, now there are 2 points. One point corresponds to x comma y on the xy plane. There is another point corresponds to x plus delta x comma y plus delta y on the xy plane. Now consider that at x comma y on the xy plane, I made an area change, not the displacement change. I made an area change. And if I make an area change, the new point is x plus delta x comma y plus delta y. How much is the area change I make? That is delta x into delta y. If delta x into delta y is the area that I have seen at point x comma y, that area corresponds to how much area on the surface. That is d position vector of the area divided by the dxy plane. This is not exactly the area, position vector of the area. Little bit different. Okay, if that is the sense, then anyway, there are 2 points here. One point belongs to x comma y, another point belongs to x plus delta x comma y plus delta y. From center, that is inside it, if I draw two lines, there are two position vectors. One position vector is xi plus yj plus zk. Another position vector is x plus delta xi plus y plus delta y plus whatever z, new z we see, that is fx plus delta x comma y plus delta yk. Okay, so that is the new height. These are the two position vectors. Now if I take these two position vector, there are 2 points. 2 points I can, now there are 2 points. Can you think about an area here? Give me other points so that I can imagine the area. If you want to imagine the area, now in the xy plane, you take the rectangle delta x delta y and take the all four side of the rectangle and all the four side. Now see where it is mapping on the surface. That is the surface that is covered by delta x delta y. That surface is covered by delta x delta y. Now divide that surface by delta x delta y, more or less, okay? Divide that surface by the delta x delta y. That is dp by dxy plane. Make sense? If there is a rectangle on xy plane, that rectangle is coming up and it is making a curved surface. What is the area of the curved surface? What is the area of the xy plane rectangle? Xy plane rectangle is delta x delta y. And curved surface area, consider it is A. A. Then dA by dx dy, dA or A by delta x delta y. That is the area. I can say that much is the area that will change if I make a 1 unit of area change along x-axis. How much is the area change if there is a delta x delta y unit of area change on the xy plane? That is delta A, what we see in the curved surface. One point is P1, that is x plus delta x comma y plus delta y comma f, x plus delta x comma y plus delta y. One point is P, that is x comma y comma fxy. It makes a curved surface. It makes a curved surface here. One point is P and one point is P1. P correspond to on xy plane x comma y. P1 correspond to another point on xy plane, that is x plus delta x comma y plus delta y. I deliberately made increment of delta x and delta y from point x comma y to show that there is a delta x delta y area change. If there is a delta x delta y area change, it will make how much area covering on the surface? That is d surface area by dxy plane or delta x delta y or dx dy, okay, into dx dy. That is the new p came into the picture. Dp, velocity vector dot d of area position vector turned into velocity vector dot d of area position vector by dxy plane into dxy plane. D of position vector by dxy plane now is same as, if I make 1 unit of area change on xy plane, how much surface area it is covering, corresponding to 1 unit of area at point x and y, because dp by dxy plane will be different at different x comma y. At any point x comma y, if there is 1 unit of area increment is there, how at point P on the surface, how much is the area increment I can see? Because that is curved, here it is flat. There is a relationship between this. One is z relationship, that is direct fxy. One is position vector relationship. Through position vector relationship I want. Okay, because I know that d of position vector is the area vector. I have showed many times. If there is a two dimension, if this is the displacement vector. Tangent at every moment is the displacement vector because it is going along the displacement. If I take any point here and from center, if I draw a position vector and if I differentiate the position vector, d of differentiation of position vector is actually displacement vector at that point. Similarly, if I have a position vector p here from center, if I do d of p there, then it becomes area vector, tangent at that point. That much I know. But how to calculate? Differentiation I cannot do directly with the x because there are two independent components, x and y. So I can do differentiation with xy plane. That makes sense. So I say d velocity vector d of position vector. D of position vector is the area vector. This is a pseudo. This is just abstract notation. Now differentiate d of position vector with xy plane because xy plane is the independent component here. X and y axis both are independent. Z is dependent. So Now I am in a phase to calculate d of position vector. If it was a curved line, then dp by dx, simple. But here it will become dp by dxy plane. dp by dxy plane, if I introduce dxy plane, I have to introduce in the numerator also d of xy plane. Then only it will be settled down. Now dp by dxy plane is, if I make 1 unit of change in xy plane at point x comma y, how many unit of change I see in the area position vector, that is dp by dxy plane. Now I took one rectangle delta x delta y. Because of that, 2 points existed now in the position vector p and p1. P is x comma y comma z, that is xi plus yj plus zk, and p1 is x plus delta x comma y plus delta y comma f function x plus delta x comma y plus delta y. Now if I am trying to calculate the, I have two vectors p and p1. What is the area it is making? To calculate the area it is making, now I have to see, I have to kind of take the x component and y component of the vector that is connecting p and p1. Vector that is p connecting p and p1 on the surface is a tangential vector. But I want area. So the tangential vector p and p1, if I connect 2 point p and p1, if I connect 2 point p and p1, it will be tangent at point p. This tangent x component and this tangent y component. Now, if I do cross product of these two components, now it will talk about the surface at that point. That surface is coming up because of the delta x, delta y change in the area change in the xy plane. So dp by dxy plane is nothing but whatever is the x component of p1 minus p vector cross whatever is the y component of p1 minus p vector. Okay, so dp1 minus p x component cross dp1 minus p y component. That is the, if I do cross product, that shows the area that is coming out here. So p1 minus p1 is x plus delta p1 minus p x component, only x component. If I see x component, then y plus delta y would go away. Only change in the x along the x axis I have to see. Now I have, if I see xy plane, I have one point, I have point x comma y. Along x axis another point is x plus delta x comma y. Along y axis I have x comma y, then other is x comma y plus delta y. Similarly, if I go on top and p1 minus p x component if I see, then the vector will be x plus delta x x minus x. Y is same. X is changing. One point to another point, x is changing. Y is exactly same because I'm taking only x component. Okay, in that sense, y delta, I mean the here, if I, this is the vector, if I take x, or this is the vector, if I take x component of the vector, then x is changing from here to here, y is not changing. If I take y component, then y is changing from here to here, x is not changing. So p1, what is p1 minus p? What is p1 minus p? p1 minus p, if I see, the p1 is x plus delta x comma y plus delta y, x plus delta x comma y plus delta y plus fx plus delta x comma y plus delta y minus fxyk. That is p1. P, let's subtract it. If someone subtract it, it becomes delta xi minus plus delta yj, delta xi plus delta yj, okay, plus fx plus delta x, fx plus delta x comma y plus delta y minus fxyk. This is straightforward p1 minus p. If I take x component of it, then what is the 2 point? If I, okay, more or less I am repeating yesterday's session. So if I take, if this is P and this is P1 on the surface. If I take X component of it and if I take Y component of it, so if I take X component of it, then it will lead to 2 points that correspond to X comma Y and X plus delta X comma Y. That will go and that will make X component of P1 minus P. So this is X comma Y comma Fxy and this is X plus delta X comma Y comma Fx plus delta X comma Y. If I take this vector, then it becomes delta x I plus fx plus delta x comma y minus fxyk. Y will go away. Okay, if I take y component, then it will be delta yj plus fx comma y plus delta y minus fxyk. Now I have to do cross product of these two so that I get the area vector. The net area vector that is getting generated because delta x delta y area on the xy plane. So now I have one vector that is delta xi plus fx plus delta x comma y minus fxyk cross product with delta yj plus fx comma y plus delta y minus fxyk. Now denominator we already have delta x into delta y. Dxy plane or dxy plane, the surface area is delta x into delta y multiplied by dxy plane. Now delta x I'll keep left side, delta y I'll shift right side of the cross product. Now it becomes delta xi plus fx plus delta x comma y minus fxyk divided by delta x cross product fx comma y plus delta y minus fxy by delta y delta yj plus fx delta yj plus fx x comma y plus delta y minus fxyk divided by delta y. First one, if I settle it down, it becomes I. It becomes I plus fx plus delta x comma y minus fxy by delta y. This is exactly as dfxy by dfxy by dx. Fx plus delta x comma y minus fxy divided by delta x is same as dfxy by dx. So first become I plus dfxy by dxk cross product j plus dfxy by dyk. This is the into dxy plane. This is the full replacement of dp. What is the net flux? What is the net flux that is coming out of this of any 3D is velocity vector dot d of initial was velocity vector d of area vector. When it came to algebra and algebra has dependent and independent component, it shifted to velocity vector dot d of surface area position vector. Surface area position vector, finally we change it into I plus dz by dx k vector cross product j plus dz by dy k vector whole multiplied with dxy plane or dx dy. That becomes d position vector and it is manageable now. Now we are in calculation of the flux that is coming out of this sphere when there is a charge that is kept q at the center. So the velocity or liquid that is coming out of the charge is q into r vector divided by r to the power 3 or q into xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. Dot product and now dot product and now I vector plus dz by dx k vector cross product with j vector plus dz by dy k vector. Let's do this cross product. It will result into minus dz by dxi minus dz by dyj plus k whole multiplied with dx dy. Now what is z? What is z in the sphere? Z in the sphere, z, if I do this dot product or complete dot product with the velocity vector, it becomes q. Q keep outside. It becomes xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. Dot product with minus dz by dxi minus dz by dyj plus k close dx dy. If I settle it down, it becomes x by x square plus y square plus x square plus y square plus z square. It is a square. In sphere, x square plus y square plus z square is a square. A square to the power 3 by 2. It becomes a to the power 3. Now it is xi by a to the power 3, yi to the a to the power 3, zi by a to the power 3. If there is some problem, then we will see. Otherwise, a to the power 3 I can keep outside. Now q by a to the power 3 I have kept outside. Now it is xi plus yj plus zk dot product with minus dz by dxi minus dz by dyj plus k. Now it becomes x into minus dz by dx. Z is square root of a square minus x square minus y square. Dz by dx is minus 2x by square root of a square minus x square minus y square. Minus dz by dx, minus become plus. Now whole it will become kind of dz by dx. Z is square root of a square minus x square minus y square. Z equal to square root of a square minus x square minus y. Dz by dx will become minus x by square root of a square minus x square minus y square. If someone settle it down, xi plus yj plus zk dot product which minus dz by dx, that is plus x by square root of a square minus x square minus y square I plus y by square root of a square minus x square minus y square j plus k dx dy. If someone settle down the dot product, it becomes x square by square root of a square minus x square minus y square plus y square by square root of a square minus y square minus z square plus k. If you settle it down, plus zk okay, x square by square root of a square minus x square minus y square ijk is gone with the dot product. Now it is x square by square root of a square minus x square minus y square plus y square by square root of a square minus x square minus y square plus z. Z is square root of a square minus x square minus y square. If someone settle it down complete, it becomes a square x square plus y square plus a square minus x square minus y square divided by square root of a square minus x square minus y square. If you settle it down, it becomes a square by square root of a square minus x square minus y square. A square and outside I have 1 by a to the power 3. 1 by a to the power 3. This is what I believe. So a square and 1 by a to the power 3, a square by 1 by a to the power 3 becomes 1 by a. Now q by a is outside. Now I have to find integration of 1 by square root of a square minus x square minus y square. 1 by square root of a square minus x square minus y square dx dy. Let's integrate y first. And limit is the circular region. The sphere is centered at the origin. If I see from the top, it is a circular region. Circle, the limit is x is minus a to a and y is minus square root of a square minus y square to square root of a square minus y square. If there is a circle is the limit, if there is a sphere that is centered at the origin, if I see from the top, then there it will form a circle on the xy plane. Circle on the xy plane, x is minus a to a and y is minus square root of a square minus x square to a square root of a square minus x square. That is the limit. But whatever we will calculate, since we are talking in x, y, z, that is for top hemisphere only, not the bottom. Then I will multiply it by 2 later. So now let integrate 1 by the square root of a square minus x square minus y square dx dy. If I integrate with the dy first, let's consider y equal to square root of a square minus x square cos theta. Then dy equal to square root of a square minus x square minus sine theta d theta. Now 1 by square root of a square minus x square minus y square. Y square I am changing it as a square minus x square cos square theta. Then whole will become 1 by square root of a square minus x square into sine theta. And top becomes a square root of a square minus x square minus sine theta d theta. Full will go away. Minus d theta will remain. If minus d theta is remaining, then minus d theta integration is theta. Theta. Now, y equal to square root of a square minus x square cos theta, then theta equal to cos theta equal to cos inverse y by square root of a square minus x square. Now I have theta, I can replace silently with cos inverse y by square root of a square minus x square. Now y is minus square root of a square minus x square to square root of a square minus x square. That will form as cos inverse 1 minus cos inverse minus 1. Cos inverse 1 is pi by 2. Cos inverse minus 1 is minus pi by 2. Settle it down, it becomes pi now. So pi is the integration. Now full dx integration is x minus a to a 2 pi a. Outside is q by a gone, 2 pi q. Q leave it right now. 2 pi is the net flux. 2 pi is the net flux. I calculated for the top hemisphere only. So if I add bottom, then 4 pi. 4 pi q. 4 pi q is the net flux that is coming out of the surface. Can you prove in other way? If I take now 4 pi q, this is what we calculated. 4 pi q. Do we have something ready-made? Yes, we have ready-made also. Now, if there is a charge, that electric charge that is kept at the center of this sphere, and the liquid, the electricity liquid that is coming out of it, equation is q into r vector divided by r to the power 3. And full spherical surface, if you see, then surface, if in a spherical coordinate system, it is everywhere perpendicular to the surface. It is radial only. If you take a sphere and see the area vector, it is radial from the center. It is in r direction only. If the surface area is in r direction and charge is also in r direction, then I can do direct multiplication of the velocity, the electricity velocity vector and surface area vector. Electricity velocity vector is q into r vector divided by r to the power 3. Dot product with the surface area vector. That is 4 pi a square, 4 pi r square. Okay, r unit vector I can say. Okay, so in that sense, these two dot product will result in angle 0, 1. So it becomes now q into r by r to the power 3, q by r square into 4 pi r square gone. 4 pi q is the net flux. Same thing we calculated from the Cartesian coordinate system. Q into 2 pi, we got it. For two hemisphere, q into 4 pi. Here also q into 4 pi. But Cartesian coordinate is more scientific because we calculated through calculus. Here I can say, consider it is the area vector is also radial everywhere. So this does not make any sense. But we can corroborate, we can verify the result. And it is the net flux that is coming out of the surface is electrical field dot area field. Electric field is q into r vector divided by r to the power 3. And area field is also in r direction. So no problem. I can go direct multiplication. Q into r by r to the power 3 dot 4 pi r square. 4 pi q. Okay, so we will proceed with the more example in this so that it will be crystal clear. If possible, then we'll try other coordinate system, and that is the end of the flux kind of computation. So that we'll see. Don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. We will see.